there's a few different advantages. So one, this is above Windows and Linux permissions. So this is really making sure that if there's a rogue domain admin or maybe a invalid GPO is pushed off somewhere, that you're not just unlocking all of that access. So even if you say a group has access to a file and folder, let's say as part of Active Directory on a Windows server, if you encrypt it, you can apply your own granular access on top to say nobody has access to this directory and only these select users do. And the access that they do have may only be write only, so they can add data, but they can't read it. For example, maybe it's a type of share where only they're to submit data but not be able to receive it back out of there. Similarly, this is taking that duty out of your domain admin's hands. But really, the biggest advantage to this is that you have centralized key management. So there should be a distinct separation of duties between who's administering your servers and adding folders and setting up permissions with domains in your architecture, and then the security behind that. So you want to make sure that any sort of encryption really is not your domain admin's responsibility, and you're able to remove that functionality from your domain admin's hands. So this is my KeySecure. So this is the enterprise key manager that I've been speaking on. And to manage it, I would just come under File Servers here. I can see my various file servers, and I have various folders that are encrypted. One is Finance and one is Marketing. So if I look at Finance here and look at the access policy, what this is saying is that by default, no one has access. There's a user called Lauren Conklin, and she has the ability to encrypt so she can add data. Scott has decrypt and encrypt so he can add or remove, and the administrator has what's called backup and restore ciphertext. So if I remote to this server here, notice this 15. Oh. So there's that finance data, and so this is finance data. So if I try to open this with WordPad, for example, all I'm going to see is just garbled data. Anywhere I take this, so if I copy it here, we'll copy it to the desktop, just garbled data. If I try to run away with it, I'll copy it to my desktop, still just garbled data. So this is that backup and restore permission that I was mentioning. So where the admin can back up that data, but in any scenario it'll always be encrypted. So if there was a disaster in some way, I could stage, let's say, a new server or maybe a new folder, encrypt it with this key, which I believe is Scott key 1, yep, Scott key 1. I could restore that data, and that way then I could apply the permissions behind it. So as the crypto admin, so I could tell my domain admin, restore the data to this directory. I'll go ahead and apply the access controls behind it, so that way the users that should be able to access can. Similarly, on the same directory, I have that user, Scott Conklin. So let's say that he comes in and he logs into his workstation. So this is Scott's workstation. He can go under, my computer. He can see that same drive, 115. It's shared out as the Z drive. He can see the finance directory. To him, he can see the data, and it's all $signs. Lauren is able to add data, but she can't necessarily read it. So if we log off and I log in as Lauren, I use my wife for most of my demos, and she has no idea. So we'll go under here, my computer, see the same directory. So I can come in here, but I have access denied. I can't read this in any way. But if I make a new directory, or new folder, rather, readme, read this. We'll save it. So I can add this, but I can't read it, even though I was the adder to it. Similarly, if I try to go back and I log in as Scott, he'll be able to read it. And if I then log in as the domain admin, so you can see there's that README file there. But if I try to open it, it's just garbled data. So that kind of shows you that clear separation of duties. You can even drill it down even more. I'm more of a Linux guy, so I always show this as my my demo for Linux, I can log in as root into my Linux server. There's a folder here called crypto folder, and there's a file called ciphertext. If I try to read it, I get permission denied. Similarly, with that same backup and restore ciphertext user, I mapped that to the user called Scott. So if he goes to this same folder here, you can just see that garbled data. Now, what's unique about this scenario is that I've drilled it down to a process. So there's a little text editor that I like to use called Nano in Linux. And what I've mapped it to is that the Nano process itself has the ability to encrypt and decrypt. So I can do Nano on the file, and I can read it from any workstation. What that really is showing is that with Protect File, I could have a server, and I could encrypt a resource, whether it's a file, a folder, a database. I could by default say no access. I could say my domain admin, which may be Scott, has the ability to back up that data, and I can only allow a certain process or application the ability to engage that resource. So that way, in the scenario, let's say I've encrypted a SQL database. By default, no one has access to it. The SQL service engine has the ability to engage it, to read and write to it, and the application that I have, maybe SAP, has the ability to engage and write to it as well. Everyone else has to go through a web portal or has to go through SAP in a certain way to engage the database, and they have two-factor authentication, so I can say when Sandy logs in, I have reasonable assurance that it's Sandy because she presented her username, password, and her OTP token, and only the application can get to that database itself or engage that resource.
How do the OS permissions look on that particular file? Like, as a root guy, could I grant access then to various people? So, yeah, do ls minus LA on that guy.
So root's the owner of that. So even if I were to change my, if I try to use SU Scott, for example, so now I'm Scott, cat the file, I still can't.
But yeah, you've granted generic permission that anyone who uses Nano now has access to that?
That's correct.
What options does the administrator of the KeySecure management console have to get himself access to data that he is managing the protection for?
Great question. So I'm logged in as admin, and that's just me. But in a general best practice, you would never have just one. You would have multiple administrators, and you would also invoke what's called multiple credentials. So in the same scenario where you need to have two people come together and turn the keys at the same time to launch the missile in the silo, this is literally the same thing, where you can say, if I enable multiple credentials, I need to have two people come together, or three people come together, or four people come together. And so if I wanted to, let's say, change permissions on a resource, so move it from encrypt and decrypt to just decrypt, or if I wanted to delete a key or push a new policy, I would need to have multiple people come together to type in their username and password or authenticate to the system to grant that operation. Also, it's just a general best practice too, because if maybe there's just one administrator and he leaves the company, or maybe he's getting fired and he just comes in and deletes all the keys, that's no good. So you definitely want to enable multiple administrators and also MFN, so that way you have all of this power with your centralized key manager, but also you're not giving them too much power because of the power that you're giving. You really want to also maintain that control as well.
Can you apply 2 of 3?
2 of 3, absolutely. Yeah, so for example, if I come under, where'd it go? Administrators, multiple credentials, I can add it and I can say, 2, or I can say 3. So what that means is, I can say I need at least 2 people, but I can have, 5, 6, 7 administrators that have the ability to change those operations. And you can get very granular as to which administrators are able to do something. So it might be where I have 5 administrators, but specifically on Protect File, I've enabled MFN for 2. So only 2 of those administrators out of my 5 have the ability to work on Protect File. So those 2 guys need to come together even though I have 5. So if another gentleman tries to log in, even though he has administrative privileges, because he's not privileged to work with Protect File, he doesn't meet that criteria.
Is that why I asked for? I'm thinking more of a quorum. You have 5 administrators. Like I say, Yeah, that's what he's saying.
Yeah.
So how does that work from just a generic usable perspective? Does that mean that I, as administrator, one, have to go and grant the permission, and then I need to go yell over the desk at administrator 2 to log in and do the same thing within a specified time period?
You can. It can be where they're just basically logging into the to the console at the same time. So if you're pushing this operation and another administrator logs in, they can grant that operation, and you can have it be in a certain time frame where is it here? With granted credentials, so you can say that you're going to grant it by and have an expiration, so you can set a time frame if you want. So that way, and the kind of the thought behind that is that, what if my administrators is remote or maybe is, going to go on vacation, but they need to have a certain application or function completed, so they can say, I'm going to grant permissions to Sandy, who normally wouldn't have permissions, between this time frame, and these are the permissions that she can execute during that time frame. So she can go into protect file and do this. Once she's done, she'll go back to her normal role. So she can kind of elevate permissions on users too. In addition to saying that I want, multiple people to come together. Automated backup and restore. So when you run through a normal backup creation process, you can select individual keys that you want to back up, individual certificates, users, groups, authorization policies. I just say select all. And the reason being is because when you get to the end, you can give it a name, a description, a password. It actually encrypts the backup itself. And you can define if you want to download it or send it to an SCP server. Once you define your SCP, you can do the authentication if it's going to be a key. So if you're going to use, let's say, a PEM or a PPK file, or if you want it to be user password. But then you can save these settings for what's called automated or remote backup. So if I were to enable this, I can say maybe every week on Saturday at 2 a.m. I want to go ahead and save that. So that way I can automatically have all of the settings securely bundled up and sent to an SCP server of my choosing. Now, if there is a disaster, and there could be a lot of different reasons for a disaster, right? Maybe your boxes have failed, or maybe, you got, you had two guys come together, they turned the key to the silo, they deleted the key, and they're like, oh crap, that was the wrong key. Well, if you needed to restore a key, you can come and select a backup. For example, I actually have one on my desktop, backup. You can define the password that you had supplied on it. And when you click restore, it doesn't just blindly restore everything. It'll actually give you this huge warning down below. And it'll let you know that there's a bunch of stuff that's in this backup that is already there, and it's going to overwrite it if you don't uncheck it. But you can get very granular by saying select none, and maybe I just want to choose that key. That was the key I accidentally deleted. So if I go through with this now, I have to type in my password again for the backup. I'll be able to restore just that one key. So high availability is key, no pun intended, by clustering your KeySecures together, but also being able to restore a backup in case there is something that happened, maybe individually deleting a key or maybe something more catastrophic.
Can different cluster nodes reside in different geographical locations?
Absolutely. I was just about to mention that. I have a lot of customers where they have it set up, let's say 2 KeySecures in New York and 2 KeySecures in LA. They're all in the same cluster. And one of the nice things about our applications is that you can choose which KeySecures to speak to. So what you can say is always try to speak to these KeySecures locally, and only if you can't speak to those, then try to reach out geographically to reach to the other KeySecures that are in the cluster. Mm-hmm. That way you can keep all of the traffic local for latency and just general security and architecture practices as well.
Yeah, so that was one of the questions I had. I mean, obviously then there's got to be some kind of a client that's installed on each individual server to enable the key authentication piece. So how sensitive is this to latency? Like, how close do I have to have the key server to my actual servers to have a smooth operation?
So great question. So one of the things that's really pretty cool about our system is that you can kind of choose where you want the crypto to occur in some of the solutions. And what I mean by that is Specifically with Protect App and Protect DB, so the application encryption and then the column level database encryption, we have what's called a properties file that defines a few things. It defines which key secures to speak to, the tiers, so if I can't speak to the key secures on tier 1, then try to reach to tier 2. Maybe tier 1 is Chicago, tier 2 is New York, and tier 3 is the UK, London. So it defines all that, but it also defines where to do the crypto. So you can, by default, have the encrypt-decrypt operations occur on the KeySecure appliance itself, or you can do local key caching, and there's two variants of it. You can do symmetric key caching, which keeps the keys in memory. They're never written to disk. We use entropy and obfuscation. We use key wrapping to bring the keys down. We use memory pinning to further protect the keys. And also, one thing I didn't speak on is that specifically with Protect DB and some of other solutions, you can provide what's called authorization policies. So when I create a key, let's say, key 1, and I give it a user, let's say Protect App, deletable, exportable, versioned, create. So I've created this key here. I can create authorization policies. So I can add, new policy. So under this new policy, I can say this can be used from Monday through Friday from 9 a.m. to 5 p.m., right? So if I go and find that key 1, permissions, I'm going to add a group. Let's say I'm going to add a Disney group. It can always be used for encryption, decrypt only during the authorization policy, and the key can never be exported. So you can get pretty granular with how you want the key to be utilized. Everything you just saw me do, this authorization policy, if you are doing local key caching, comes with the key. So as the key resides in the cache, if further requests for that key are needed, it'll actually abide by the rules that we just set up here. So Protect App and Protect DB specifically can do local key caching. So really in that regard, the proximity to the KeySecure doesn't matter because it's handling the key itself. And then the other solutions like Protect File, Protect V, those have an agent that you would install on your Windows or Linux operating system. So similarly, like in Linux, I have an agent called, let's see if it's up at the top there. It's not. It's a safenet _PF, and there's an agent that's running on Windows. But what happens is when you go to work with Protect File, there's a few things that you define. And I'll actually walk you through that. So here's my server. Let's go to New Volume, New Folder, Encrypted. Let's make a new file inside. Test. Okay, so that's encrypted, so let's go find it. So for Protect File, this is essentially how you would select resources to encrypt. And you can script all this too if you want an API.
Is that the only way? Is that the only way that everything has to be done through the console?
No, you can script all this from an API if you want as well.
Okay. Mm-hmm. Okay. Thanks.
Yeah. So I'll select this folder here called encrypted. So I've selected the path I want to encrypt. I'll select a key that I want to encrypt it with. Let's say key 1. I'll create an access policy behind it. And what that means is when I go and create this access policy, I'll say by default no one has access, and maybe administrator has backup and restore ciphertext. So these are those different permissions that you've heard me speaking on. And then specifically, it shows you if you can use local users and groups, domain users and groups, or processes. Once I've kind of set up the permissions behind that, once I'm ready, I can then basically say go. So in this model here, what's happening is that I'm pushing the path to be encrypted, the key itself, and the policy to the agent. So once that resource is encrypted, the agent handles onto that. So all further encrypt decrypt requests to either deliver the data in a decrypted content or to encrypt new data that's introduced to the directory, if you've encrypted a directory, is governed by that agent. So in this model too, with those solutions I mentioned, the proximity to the KeySecure is not relevant.
And all this encryption is symmetric encryption, I guess?
It is symmetric encryption, that's correct.